Dear students, in previous video we have seen that overfitting is occurring because the model is not performing well on unseen data. Model is performing poorly during your testing phase. But why overfitting has occurred? Because your data set is containing noisy data. Noisy data means what? Data that is not related to our problem. Unrelated data, missing data, impaired data, imbalanced data, unwanted data. So these are all the data which are causing overfitting. Now, one of the technique to avoid overfitting in decision tree is pruning. So what do you mean by pruning and how we can apply it? What are its types? That all we are going to see in this video. Now, as we are performing the recursive induction in decision tree, it will grow in big size. In all our examples, we have seen the trees of 3 to 4 levels only. But suppose if I want to construct a tree which is containing India at its root level, then all the states in India in the next level, then all the cities in India in next level, then all the holiday spots in those cities in next level, then imagine how big will be that decision tree. If your decision tree is simple, it is developed only by using a single feature, then it is called as a decision stump. Okay. Now, what is the disadvantage of this decision stump is it will cause overfitting. Then pruning is a solution to avoid overfitting. Now, there are two types of the pruning, pre-pruning and post-pruning. Pre-pruning means what? It will be implemented when you are building the tree. But once your tree is ready completely, means it has been built completely, and then you want to avoid the overfitting, then it is called as a post pruning. So because of this pruning, what is happening is we can improve the accuracy of the model. But while pruning, we should take care that the accuracy of the model should not be affected. Now pruning means what? What we are doing is we are shrinking our decision tree. Means the nodes which are not at all visited, those nodes we are removing. That is what the pruning means. It is useful for the huge and complex model. Now, as I told you in previous example that I am developing a tree which is containing the holiday spots for each of city in India. Then there may be some spots which are not at all visited. Then those nodes are not useful to me, then simply I will remove those nodes. That is what called as a pruning. So it will improve the speed as well as the efficiency of your decision tree. Now, generally our decision tree is a binary tree. But if it is having the multi-class classification, then it may have overfitting and it will lose the generalization capacity. So what the pruning is doing, it is eliminating unnecessary branches or nodes from the decision tree, resulting in smaller and simpler model that is less liable to overfit. That is not making your model ungeneralized. So pruning is trying to get optimal decision tree. Okay. It means if you are having too large tree, then it is having the risk of the overfitting. There may be some nodes in your decision tree which are never visited. Then no use of keeping them in your decision tree. Simply you have to remove it. So what are the types of the pruning? Pre-pruning and post-pruning. As I told earlier, pre-pruning means what? When you are developing your decision tree, at that time only you will try to avoid some nodes. Then it is called as a pre-pruning. Now how you can avoid? You can keep a threshold for depth of your tree. If you have reached that threshold, stop it. Then how many samples for each leaf you can have? For that also you can maintain a threshold. How many samples per split you want? That also you can limit. Then how many features you are including in the decision tree for splitting purpose, that also you can decide. So these are the criteria which are used for pruning at early stage, means when you are developing your decision tree. Now, the next pruning will come when you have developed your tree completely. You have kept your tree for testing phase. It is not working well in testing phase. It is causing overfitting. The tree is not generalized. Then in such case, I will apply the post pruning technique. Now here, based on the cost of each subtree, I will remove the subtree. Then the next one is I will remove the branches. Those are affecting the accuracy of my decision tree. Now, in some cases, I want impurity. Means up to a certain threshold, I can bear the impurity. But if that impurity is not existing because of some nodes, I will remove it. Then I will remove the leaf nodes if they are having only fewer samples than a specified threshold. So these are the techniques which I will use to avoid overfitting, to get a generalized decision tree. So, what are the advantages of decision tree? Till now, we have seen all the concept of the decision tree, but what advantages you find for this decision tree? It is capable of representing the concept in the real life. It is replicating the decision making process in a human brain, and it is useful to solve the decision related problem because it is capable of showing all the possible outcome, and there is no data preprocessing required as compared to other algorithms for decision tree. Now, what are the disadvantages is if the number of layers are increasing, then it is becoming more and more complex, and sometimes it will cause a overfitting issue. And if we are having the multi-class classification, then in that case, computation complexity of decision tree may increase. So these are all the disadvantages of decision tree. I hope you have understood what do you mean by decision tree, what are its terminologies, what is the entropy information gain, and what is the ID3, and how you can apply the ID3 on data set, how to avoid overfitting, how you can use decision tree for searching, and what do you mean by pruning. So these are all the concepts covered in this unit, and this is the last video of this unit. Thank you.